October 15th, 1944. 28,000 feet above Leipzig, Germany. Hauptmann Erich Hartmann banked his Messerschmitt Bf 109 G6 hard to starboard, the Daimler-Benz DB 605 engine screaming at maximum power. Below him, a formation of American B-17 flying fortresses approached their target, protected by something that made his blood run cold. Sleek, angular fighters that seemed to appear from nowhere, moving faster than anything the Luftwaffe had encountered. The small fuselage placard would read P-51D Mustang, but Hartmann couldn't read it from this distance. He only knew that his squadron of veteran pilots, flying the backbone fighter of the Reich, was about to encounter an aircraft that would shatter everything they believed about air superiority. The first pass revealed the terrible truth immediately. Hartmann dove on what appeared to be a straggling Mustang. His wing-mounted 20mm MG-151 cannons and fuselage-mounted 13mm MG-131 machine guns, ready to deliver the killing blow that had made him the highest-scoring ace in aviation history, with over 300% and confirmed victories. The American pilot saw him coming. Instead of taking evasive action, the Mustang simply accelerated. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What happened next defied everything Hartmann had learned about fighter combat. The Mustang pulled away from his Bf 109 as if his aircraft were standing still. The American fighter's Packard V16507 engine, a license-built version of the Rolls-Royce Merlin 66, produced 1,490 horsepower through its two-stage, two-speed supercharger. More crucially, it maintained that power at altitudes where the Bf 109's single-stage supercharger began to falter. At 28,000 feet, Hartmann's supposedly superior fighter was producing barely 1,100 horsepower. The power differential translated into a speed advantage that seemed impossible. The Mustang accelerated past 440 miles per hour in level flight, a speed that Hartmann's Bf 109 G6 could barely achieve in a dive. The American pilot wasn't running, he was positioning for his own attack. The revelation struck Hartmann like a physical blow. For 3 years, Luftwaffe pilots had dominated European skies flying aircraft that combined speed, climb rate, and maneuverability in perfect balance. The Bf 109 had been refined through constant combat experience into what German engineers considered the pinnacle of fighter design. Small, light, efficient, deadly. Every component optimized for performance, every gram of weight scrutinized, every design choice focused on creating the perfect air superiority weapon. The Americans had apparently built something entirely different. They had created a fighter that simply overwhelmed opposition through brute performance. The Mustang wasn't trying to outmaneuver the Bf 109. It didn't need to. It could outrun it, outclimb it, and outdive it while carrying enough fuel to escort bombers all the way to Berlin and back. Hartmann's wingman, Unteroffizier Gerhard Theiben, had engaged another Mustang with similarly disastrous results. Theiben was an experienced pilot with 47 confirmed victories, a veteran of the brutal air battles over the Eastern Front, where he had learned to extract maximum performance from his aircraft through precise energy management. Against the Mustang, his experience meant nothing. The American pilot had turned into Theiben's attack, converting the energy of Theiben's dive into a climbing spiral that should have bled off the Mustang's speed and given the Bf 109 the advantage. Instead, the Mustang maintained its climb rate while tightening its turn radius, a combination that violated everything Theiben understood about fighter aerodynamics. The Merlin engine's power curve remained flat at altitude, providing sustained performance that the DB 605 simply couldn't match. Within minutes, both German pilots found themselves in the unprecedented position of being outclassed by an enemy fighter that seemed to excel in every performance category simultaneously. The Mustang was faster in level flight, faster in the climb, faster in the dive. Its turn rate, while not matching the Bf 109's instantaneous response, proved sustainable through multiple reversals. Most troubling of all, the American pilots flew with the confidence of men who knew their aircraft's superiority. The encounter lasted less than 10 minutes. Hartmann and Theiben disengaged, not because they had accomplished their mission, but because continuing the fight would have meant certain death. They returned to their base at Tulau with a story that their commanding officers initially refused to believe. The Americans had a fighter that outperformed the Bf-109 across the board. The implications were staggering. By October 1944, the Messerschmitt Bf-109 had been in continuous production for 8 years. The basic airframe design dated to 1934, when Willy Messerschmitt's team created what they believed would be the definitive European fighter. Through constant refinement, the aircraft had evolved from the Bf-109B through the current G-series, each variant incorporating lessons learned in combat and improvements in German aviation technology. The Bf-109G6, which equipped the majority of Luftwaffe fighter squadrons in late 1944, represented the culmination of this evolutionary process. Powered by the Daimler-Benz DB 605, a one-engine producing 1,275 horsepower for takeoff, the aircraft weighed approximately 7,000 pounds loaded and could achieve a maximum speed of 386 miles per hour at 22,000 feet. German engineers had achieved this performance through meticulous attention to aerodynamic efficiency and weight reduction. The Bf-109's wing loading was relatively high, but its power-to-weight ratio provided excellent climb performance at low to medium altitudes. The aircraft's small size made it difficult to hit in combat, while its heavy armament could destroy any Allied fighter with a short burst. Most importantly, the Bf-109 had been designed specifically for the European theatre, where combat typically occurred at altitudes between 15,000 and 25,000 feet. At these altitudes, the DB-605 engine performed optimally, providing the power necessary to maintain air superiority against British Spitfires and American P-47 Thunderbolts. The Americans had apparently designed the P-51 Mustang according to completely different parameters. North American Aviation had created the aircraft in 1940, initially powered by the Allison V-1710 engine, which proved inadequate for high-altitude combat. The transformation occurred when British engineers suggested replacing the Allison with the Rolls-Royce Merlin, creating what would become the P-51B variant in 1943. The marriage of American airframe design with British engine technology produced results that surprised even the aircraft's creators. The Merlin 66 engine, manufactured under license by Packard as the V16507, incorporated a two-stage, two-speed supercharger that maintained sea-level power output to altitudes exceeding 25,000 feet. This high-altitude performance capability transformed the Mustang from a capable ground attack aircraft into the finest air superiority fighter of the war. The P-51D variant that Hartmann and his pilots encountered weighed approximately 12,000 pounds loaded, nearly twice the weight of the Bf-109 G6. German intelligence officers, analyzing crashed Mustangs, initially dismissed the aircraft as another heavy American fighter that sacrificed performance for durability, similar to the P-47 Thunderbolt. They were catastrophically wrong. The Mustang's additional weight came primarily from fuel capacity. The P-51D carried 184 gallons internally, supplemented by external drop tanks that could extend its range to over 2,000 miles. This fuel capacity allowed the aircraft to escort bombers to any target in Germany while retaining sufficient fuel for extended combat. More critically, the Mustang's aerodynamic design proved superior to the Bf-109's most flight regimes. North American's engineers had optimized the airframe for high-speed flight, incorporating a laminar flow wing section that reduced drag at high velocities. The aircraft's clean lines and careful attention to surface finish produced a level of aerodynamic efficiency that German designers had not achieved. The result was an aircraft that could cruise at 350 miles per hour while burning less fuel per mile than the Bf-109, despite its larger engine and heavier weight. In combat conditions, the P-51D could achieve maximum speeds exceeding 440 miles per hour in level flight, a performance figure that the Bf-109G6 could not match at any altitude. Luftwaffe intelligence services had been tracking American fighter development since early 1942, when the first P-51B variants appeared in small numbers over Western Europe. Initial reports dismissed the aircraft as another escort fighter with limited combat capability. The Mustang's early combat record seemed to confirm this assessment. American pilots flying the type achieved modest success rates against experienced Luftwaffe opposition. The situation changed dramatically in early 1944 when large numbers of P-51D variants began appearing over Germany. These aircraft carried improved armament, enhanced pilot protection, and most importantly, they were flown by American pilots who had completed extensive training in high-altitude combat tactics specifically designed to exploit the Mustang's performance advantages. The impact on Luftwaffe operations was immediate and devastating. German fighter squadrons that had maintained local air superiority through superior tactics and pilot experience found themselves outclassed by an aircraft that could choose when and where to engage. Mustang pilots could initiate combat from advantageous positions, press attacks home with overwhelming speed and firepower, then disengage before German pilots could respond effectively. The psychological impact proved as damaging as the material losses. Luftwaffe pilots who had dominated European skies for 3 years suddenly found themselves flying inferior aircraft against opponents who held every tactical advantage. Combat became a matter of survival rather than victory. German pilots learned to avoid engagement with Mustangs whenever possible, a tactical approach that effectively conceded air superiority to the Americans. Hauptmann Hartmann returned to Tulau that October afternoon, with more than battle damage to his aircraft. He carried the knowledge that German air superiority was ending, not through pilot error or tactical mistakes, but through simple technological obsolescence. The Bf-109, for all its refinement and combat experience, had been surpassed by an aircraft that represented a fundamental advancement in fighter design. The debriefing that followed Hartmann's mission became one of thousands conducted throughout the Luftwaffe, as pilots reported encounters with American aircraft that exceeded their capabilities. The pattern was consistent across all fronts. German pilots engaging P-51 Mustangs found themselves at disadvantages that skill and experience could not overcome. Oberst Adolf Galland, general of the fighter arm, received these reports with growing alarm. Galland was not only the Luftwaffe's senior fighter commander, but also an experienced combat pilot with 104 confirmed victories. He understood immediately what the pilot reports represented. The Americans had achieved technological superiority that rendered German fighters obsolete. Galland's analysis, submitted to Reich Marshal Hermann Göring in November 1944, was blunt in its assessment. The enemy possesses fighters that exceed the performance of our best aircraft in every meaningful category. The P-51 Mustang combines speed, range, and firepower in a package that our pilots cannot match. We are asking our men to engage superior aircraft with inferior equipment. This is not sustainable. The report included specific performance comparisons based on flight tests of captured P-51D aircraft. At 30,000 feet, the Mustang could outrun the Bf-109G6 by over 60 miles per hour. The American aircraft's service ceiling exceeded 42,000 feet, nearly 5,000 feet higher than the German fighter. Most critically, the Mustang could maintain combat power at altitudes where the Bf-109's performance degraded significantly. German test pilots conducting evaluation flights on captured Mustangs provided even more sobering assessments. Major Hans-Joachim Marseille, who had scored 158 victories before his death in September 1942, had previously evaluated captured Allied fighters and found them inferior to German equipment. His successor, Hauptmann Wolfgang Späti, flew the captured P-51D at the Rechlin Test Center and submitted a report that shocked Luftwaffe leadership. This aircraft represents a generational advancement over anything in our inventory. The engine-airframe combination produces performance levels that we cannot match with current technology. The pilot who flies this aircraft possesses advantages that make victory almost inevitable against any German fighter currently in service. We must develop countermeasures immediately, or concede air superiority permanently. The countermeasures never materialized. German industry, strained by constant bombing and material shortages, could not produce sufficient quantities of advanced aircraft to challenge American numerical superiority. The Messerschmitt Me 262 jet fighter showed promise but arrived too late and in numbers too small to affect the war's outcome. Meanwhile, American production of P-51 Mustangs accelerated through 1944 and into 1945. North American aviation delivered over 15,000 examples of all variants, with the majority reaching European combat units during the final 18 months of the war. These aircraft equipped not only American fighter groups but also British, Canadian, and Australian squadrons that used the Mustang's range and performance to dominate Axis fighters throughout the European theatre. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The human cost of this technological disparity became evident in Luftwaffe casualty statistics. German fighter pilot losses increased dramatically after the introduction of large-scale P-51 operations in early 1944. Experienced pilots who had survived years of combat found themselves shot down by American opponents flying superior aircraft. The loss rate was unsustainable. The Luftwaffe had begun the war with approximately 4,000 trained fighter pilots. By late 1944, fewer than 800 remained operational. Replacement pilots received minimal training due to fuel shortages and the constant threat of Allied bombing of training facilities. These inexperienced pilots, flying obsolescent aircraft against superior opposition, had virtually no chance of survival. Hartmann himself survived the war, though many of his squadron mates did not. In post-war interviews, he consistently credited American technological superiority, particularly the P-51 Mustang, with the Luftwaffe's defeat. The aircraft was simply better than anything we had. Faster, longer-ranged, better armed. Our pilots were fighting with one hand tied behind their backs. The final major air battle involving large numbers of Bf 109 seconds occurred on January 1, 1945, during Operation Bodenplatte, the Luftwaffe's last major offensive against Allied airfields. German fighters achieved tactical surprise and destroyed significant numbers of Allied aircraft on the ground. However, the operation cost the Luftwaffe over 200 aircraft and nearly 300 pilots, losses that could not be replaced. Many of the German losses came during air-to-air combat with P-51 Mustangs that intercepted the returning German formations. American pilots, flying aircraft that held overwhelming performance advantages, achieved kill ratios exceeding 10-1. The Luftwaffe never recovered from these losses. Organized resistance in the air effectively ended with Bodenplatte. The final assessment belongs to the pilots who flew both aircraft. After the war, several Luftwaffe veterans had the opportunity to fly P-51 Mustangs as part of technical evaluation programs. Their reactions were uniformly impressed. Oberst Johannes Steinhoff, a veteran of over 900 combat missions who had scored 176 victories flying the Bf 109, flew a P-51D at Wright Field in 1946. His evaluation report captured the technological gap that had decided the air war. The Mustang is everything the Bf 109 should have been but never became. The engine provides power across the entire altitude envelope. The controls are responsive at all speeds. The range allows extended operations impossible with German fighters. Most importantly, the aircraft forgives pilot errors that would prove fatal in the Bf 109. This forgiving nature proved crucial in training American pilots for combat. The P-51's stable handling characteristics allowed relatively inexperienced pilots to exploit the aircraft's performance advantages without requiring the years of training that German pilots needed to master the more demanding Bf 109. American training programs could produce competent Mustang pilots in months rather than years. The broader implications extended far beyond individual aircraft performance. The P-51 Mustang represented American industrial capability applied to military aviation. The aircraft incorporated advanced metallurgy, precision manufacturing, and sophisticated engineering in a package that could be mass-produced by semi-skilled workers. Over 15,000 examples were delivered in less than 4 years, a production rate that German industry could not match. More fundamentally, the Mustang embodied a different approach to fighter design, where German engineers optimized for specific combat scenarios based on European conditions. American designers created an aircraft capable of excelling across a broad range of missions and altitudes. This versatility proved decisive in a global conflict that demanded aircraft capable of operating effectively across vastly different theaters and conditions. The technological lessons learned from the P-51's development influenced post-war aviation development worldwide. The aircraft's combination of aerodynamic efficiency, powerful engines, and long range became the template for jet fighters developed in the 1950s and 60s. Many of the engineers who designed the Mustang went on to create the next generation of American fighter aircraft, incorporating lessons learned from the war's most successful air superiority fighter. German aviation engineers, working under Allied supervision during the post-war period, studied captured Mustangs extensively. Their reports acknowledged the aircraft's superiority while analyzing the design decisions that had made such performance possible. These studies influenced the development of European jet fighters and helped establish design principles that remain relevant today. The personal impact on the pilots who flew against the Mustang lasted long after the war ended. Veterans organizations on both sides maintained correspondence throughout the post-war period, with former enemies sharing their experiences and perspectives. These exchanges revealed consistent themes. German pilots acknowledged American technological superiority, while American pilots respected German skill and courage. At a 1965 reunion of the 8th Air Force Association, several former Luftwaffe pilots attended as honored guests. The conversations between former enemies revealed mutual respect and understanding. Hartmann, by then a brigadier general in the reformed German Air Force, spoke about his wartime experiences flying against American fighters. The P-51 was the aircraft that ended German air superiority, not through any fault of our pilots or tactics, but through simple technological advancement. The Americans had built a better fighter. In war, that usually decides the outcome. We learned to respect the aircraft and the men who flew it. They earned their victory through superior engineering and industrial capacity. The Mustang's legacy extended beyond its combat record. The aircraft proved that technological superiority could overcome experience and tactical skill when the performance gap became too large to bridge. This lesson influenced military aviation development throughout the Cold War, driving continuous advancement in fighter aircraft capability. Today, several airworthy P-51 Mustangs participate in air shows worldwide, often flying alongside restored Bf 109 seconds in demonstration flights that recreate the aerial battles of World War II. These displays allow modern audiences to witness the speed and grace of both aircraft, while honoring the memory of the pilots who flew them in combat. Veterans of both air forces occasionally attend these events, elderly men now in their 90s who once tried to kill each other in the skies over Europe. Their conversations reveal the complexity of war, the respect that develops between professional warriors, and the enduring fascination with the machines that decided the fate of nations. The story of the Luftwaffe's encounter with the P-51 Mustang is ultimately a story about technological change and its consequences. German pilots, flying aircraft that had dominated European skies for 3 years, suddenly found themselves outmatched by an opponent that held every advantage. Their skill and courage could not overcome the simple reality that they were flying inferior machines against superior opposition. The admission came reluctantly, extracted through bitter experience and undeniable evidence. German pilots who had entered the war believing in their equipment's superiority learned through painful encounters that American engineering had surpassed German technology. The realization marked the end of Luftwaffe air superiority and contributed directly to Germany's defeat. Hartmann's experience above Leipzig, multiplied across thousands of similar encounters, represented more than tactical defeats. These air battles demonstrated the decisive importance of technological superiority in modern warfare. The side that could produce better equipment in larger quantities would ultimately prevail, regardless of the skill and determination of individual warriors. The P-51 Mustang proved this principle conclusively. American pilots flying superior aircraft defeated German pilots flying obsolescent fighters, not through superior skill or training, but through the simple advantage of better technology. The lesson influenced military thinking for generations and continues to drive technological competition between nations today. In the end, the Luftwaffe pilots who intercepted P-51 seconds at 440 miles per hour learned a humbling truth. Their Bf 109 seconds, for all their refinement and combat heritage, had been outmatched by an aircraft that represented the next generation of fighter design. The Americans had built a better fighter, and in aerial combat, that advantage proved decisive. The German pilot's admission of inferiority marked more than a tactical acknowledgement. It represented the recognition that the war's technological tide had turned irreversibly against Germany. The Mustang was not just a superior fighter. It was a symbol of American industrial might and engineering capability that Germany could not match. The sky above Leipzig, that October day, witnessed more than an air battle. It hosted a collision between two technological philosophies, two approaches to fighter design, two nations' understanding of modern warfare. The outcome was predetermined by decisions made in engineering offices and factory floors thousands of miles from the combat zone. German pilots learned to fear the sleek silhouette of the approaching Mustang, knowing that engagement meant fighting at a disadvantage that skill could not overcome. American pilots flew with the confidence that comes from technological superiority, pressing attacks home against opponents who could not match their aircraft's performance. The final lesson belongs to history itself. The P-51 Mustang's dominance over the Bf 109 demonstrated that wars are won not just by brave soldiers and skilled pilots, but by the nations that can produce superior weapons in sufficient quantities. Technology, combined with industrial capacity, proved more decisive than tradition, experience, or individual heroism. The Luftwaffe pilots who realized their Bf 109 seconds were outmatched had learned this lesson the hard way. Their admission stands as testimony to American engineering achievement and as recognition that the age of German air superiority had ended forever. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The technological gap between the P-51 Mustang and the Messerschmitt Bf 109 extended far beyond simple performance statistics. The difference represented two fundamentally opposed philosophies of aircraft design, manufacturing, and military doctrine. Understanding this divide requires examining not just what these aircraft could do, but how they were conceived, built, and employed by their respective air forces. The Messerschmitt Bf 109's development began in 1934 under the leadership of Professor Willy Messerschmitt, whose design philosophy emphasized aerodynamic efficiency and structural minimalism. Every component was scrutinized for weight reduction, every surface optimized for minimum drag. The resulting aircraft achieved remarkable performance from relatively modest power, a testament to German engineering precision. The Bf 109's construction reflected this philosophy. The fuselage was built around a central backbone structure that provided maximum strength with minimum weight. The wing was attached to this backbone through 4 mounting points, creating a clean structural design that minimized parasitic drag. The aircraft's small size made it inherently difficult to manufacture, requiring skilled craftsmen to achieve the precise tolerances necessary for proper fit and finish. This approach worked brilliantly during the aircraft's early years. The Bf 109 B and C variants dominated the Spanish Civil War, demonstrating clear superiority over Republican aircraft. The improved D and E variants achieved air superiority over Poland, Norway, France, and initially over Britain during the Battle of Britain. The aircraft's combination of speed, climb rate, and firepower made it the world's premier fighter through 1942. However, the design's optimization for specific conditions became a liability as the war expanded. The Bf 109's small size limited fuel capacity, restricting range to barely 300 miles. The narrow landing gear, retracted into the wing roots, made ground handling treacherous, and caused numerous accidents. Most critically, the airframe's tight packaging left little room for improvement or modification. By 1943, the Bf-109G represented the limits of development within Messerschmitt's original design parameters. Additional equipment and armor had increased weight without corresponding increases in power, degrading performance across all flight regimes. The aircraft that had once dominated European skies was approaching obsolescence, constrained by design decisions made nearly a decade earlier. The P-51 Mustang emerged from completely different circumstances and design philosophy. North American Aviation received the initial contract in April 1940, when the British Purchasing Commission requested a fighter aircraft for delivery within 120 days. The company's chief designer, Edgar Schmood, created an aircraft that prioritized aerodynamic efficiency over structural minimalism. Schmood's team conducted extensive wind tunnel testing to optimize the airframe's drag characteristics. The resulting design featured a laminar flow wing section that maintained smooth airflow over a greater percentage of the wing's surface, reducing drag at high speeds. The fuselage was carefully shaped to minimize interference drag where the wing joined the body. Every surface was refined to achieve maximum aerodynamic efficiency. Critically, the Mustang was designed from the beginning to accommodate different engines and equipment configurations. The airframe could accept various power plants, weapons systems, and fuel configurations without major structural modifications. This flexibility proved decisive when British engineers suggested replacing the original Allison V-1710 engine with the Rolls-Royce Merlin. The engine change transformed the aircraft's capabilities completely. The Allison engine had provided adequate performance at low altitudes, but suffered significant power loss above 15,000 feet. The Merlin's two-stage supercharger maintained sea-level power to altitudes exceeding 25,000 feet, creating a high-altitude interceptor that exceeded all existing fighters' performance. More importantly, the Merlin installation demonstrated the Mustang airframe's adaptability. Engineers accomplished the engine change with minimal modifications to the basic structure, proving that the original design possessed the flexibility necessary for continuous improvement. This adaptability would prove crucial as combat requirements evolved throughout the war. The manufacturing philosophy behind each aircraft reflected their respective nations' industrial capabilities and wartime priorities. German production of the Bf-109 relied heavily on skilled craftsmen, working in relatively small facilities. Each aircraft required approximately 20,000 man-hours to complete, with much of the work performed by experienced technicians who could achieve the precise tolerances necessary for proper performance. This approach produced excellent aircraft but limited production capacity. German factories delivered approximately 34,000 Bf-109 seconds during the entire war, with peak monthly production reaching barely 400 aircraft. The reliance on skilled labor meant that production could not be easily expanded, particularly as experienced workers were drafted for military service. American production of the P-51 followed completely different principles. North American Aviation designed the aircraft for mass production using semi-skilled workers and standardized manufacturing processes. The company developed specialized tooling and assembly line techniques that reduced the skill level required for aircraft construction. The results were dramatic. North American delivered over 15,000 P-51 seconds in less than 4 years, with peak monthly production exceeding 500 aircraft. More importantly, the manufacturing process could be rapidly scaled up by training additional workers and building new facilities. American industry demonstrated the capacity to overwhelm German production through superior manufacturing efficiency. The fuel systems of both aircraft illustrated their different design priorities and the consequences of those choices. The Bf-109G6 carried 109 gallons internally, stored in a single fuselage tank located directly behind the pilot. This configuration minimized weight and complexity but severely limited range. Additionally, the fuel tank's location made it vulnerable to enemy fire, with hits often resulting in immediate fires that gave pilots little chance of escape. The P-51D carried 184 gallons internally, distributed among multiple self-sealing tanks located in both the fuselage and wings. This configuration provided nearly twice the range while offering superior protection against battle damage. The self-sealing tanks could absorb multiple hits without losing fuel pressure or creating fire hazards. More significantly, the Mustang could carry external drop tanks totaling up to 110 additional gallons, extending its range to over 2,000 miles. This capability allowed the aircraft to escort bombers to any target in Germany while retaining sufficient fuel for extended combat. The Bf-109's limited internal capacity made such missions impossible. The armament systems reflected similar philosophical differences. The Bf-109G6 carried one 30mm Mk-108 cannon firing through the propeller hub, supplemented by two 13mm MG-131 machine guns mounted above the engine. This arrangement provided devastating firepower against bomber targets but required pilots to close to short range for effective hits. The cannon installation also created significant problems. The 30mm weapon's slow rate of fire and pronounced ballistics made accurate shooting difficult, particularly against maneuvering fighter targets. The weapon's recoil affected aircraft handling, while its ammunition capacity was limited to 60 rounds. Experienced pilots could exhaust their cannon ammunition in less than 6 seconds of firing. The P-51D mounted 6 50-caliber M2 Browning machine guns in the wings, with a total ammunition capacity of 1,800 rounds. This arrangement provided sustained firepower with flat ballistics that made accurate shooting easier. The weapon's high rate of fire created a dense pattern of projectiles that increased hit probability against maneuvering targets. More importantly, the wing-mounted installation did not affect aircraft balance or handling characteristics. Pilots could fire continuously for extended periods without degrading flight performance. The larger ammunition capacity allowed for multiple engagements without requiring return to base for rearming. The pilot protection systems demonstrated the most dramatic difference between German and American design philosophy. The Bf-109G6 provided minimal armor protection, consisting of a small armored glass windscreen and a thin armor plate behind the pilot's head. Total armor weight was approximately 60 pounds, kept minimal to preserve performance. This approach reflected German confidence in pilot skill and aircraft maneuverability to avoid enemy fire. Luftwaffe training emphasized aggressive tactics and superior positioning to prevent enemy aircraft from achieving firing solutions. The philosophy worked well when German pilots held tactical advantages, but proved inadequate when facing superior aircraft. The P-51D incorporated comprehensive pilot protection weighing approximately 160 pounds. Armor plating protected the pilot from multiple angles, while bulletproof glass provided protection without significantly restricting visibility. Self-sealing fuel tanks and protected vital systems further enhanced survivability. The additional protection reflected American understanding that pilot survival was more important than marginal performance gains. Combat analysis demonstrated that experienced pilots were far more valuable than individual aircraft, making pilot protection a critical design priority. The investment in protective systems paid dividends throughout the war, as American pilots survived encounters that would have proven fatal in less protected aircraft. The engine installations revealed fundamental differences in approach to power plant integration. The Bf-109's Daimler-Benz DB 605 was optimized for high power output at low to medium altitudes, where most European combat occurred. The engine's single-stage supercharger provided excellent performance below 20,000 feet, but suffered significant power loss at higher altitudes. German engineers had accepted this limitation because intelligence assessments suggested that high-altitude combat would remain uncommon. The decision proved catastrophic when American bombing campaigns forced combat to altitudes exceeding 25,000 feet, where the DB-605's performance degraded severely. The Packard V16507 Merlin in the P-51D was specifically designed for high-altitude operations. The two-stage, two-speed supercharger maintained sea-level power output to altitudes exceeding 30,000 feet, providing consistent performance across the entire operational envelope. This capability proved decisive in combat against aircraft optimized for lower altitude operations. More significantly, the Merlin's power curve remained relatively flat throughout its altitude range, while the DB-605's power fell off dramatically above 20,000 feet. This difference meant that at combat altitudes, the Mustang possessed overwhelming power advantages that translated directly into superior performance in every flight regime. The cockpit designs reflected each nation's approach to pilot interface and aircraft operation. The Bf-109's cockpit was notoriously cramped, with controls positioned for minimal space rather than pilot convenience. The narrow fuselage forced pilots of average height to hunch their shoulders, while taller pilots found the cockpit nearly unusable. Visibility was severely restricted by the aircraft's high cowling and narrow canopy. The pilot's view forward was blocked by the large engine installation, while rearward visibility was limited by the aircraft's structure. These limitations made formation flying difficult and reduced situational awareness during combat. The P-51's cockpit provided superior ergonomics and visibility. The pilot sat in a spacious environment with controls logically arranged for ease of operation. The aircraft's lower cowling line and large bubble canopy provided excellent visibility in all directions, crucial advantages during combat maneuvering. The improved visibility translated directly into tactical advantages. Mustang pilots could spot enemy aircraft earlier and maintain visual contact throughout engagements. The superior ergonomics reduced pilot fatigue during long missions, maintaining effectiveness during extended operations that would exhaust pilots flying less comfortable aircraft. The maintenance requirements of both aircraft reflected their different design philosophies and manufacturing approaches. The Bf-109 required specialized tools and highly trained mechanics for routine maintenance. The aircraft's tight packaging made many components difficult to access, extending routine service times and complicating field repairs. Engine changes required approximately 12 hours, with a full crew of experienced mechanics. Control system adjustments needed factory-trained technicians familiar with the aircraft's complex rigging requirements. These maintenance characteristics limited the aircraft's operational availability and reduced its effectiveness in sustained combat operations. The P-51 was designed from the beginning for ease of maintenance. Standard tools could accomplish most routine tasks, while the aircraft's larger size provided better access to critical components. Engine changes could be completed in 4 hours by mechanics with basic training, while routine maintenance required minimal specialized knowledge. This maintainability translated into higher operational availability rates. Mustang squadrons could maintain larger percentages of their aircraft in flyable condition, providing numerical advantages that complemented the aircraft's performance superiority. German units often operated with less than 50% of their assigned aircraft available due to maintenance requirements. The training requirements for pilots transitioning to each aircraft type demonstrated another crucial difference. The Bf-109's demanding handling characteristics required extensive training for safe operation. The aircraft's narrow landing gear made ground handling treacherous, while its high wing loading demanded precise speed control during approach and landing. New pilots required approximately 60 hours of training before achieving basic proficiency, with additional time needed to master combat techniques. The aircraft's unforgiving handling characteristics meant that pilot errors often resulted in accidents or combat losses. This training requirement became critical as experienced instructors were transferred to combat units. The P-51's more forgiving handling characteristics allowed pilots to achieve basic proficiency in approximately 30 hours of training. The aircraft's stability and predictable behavior reduced accident rates during training and allowed less experienced pilots to exploit its performance advantages effectively. This training efficiency proved crucial as American pilot production accelerated. The strategic implications of these technical differences became apparent as the air war intensified. German fighter units found themselves operating aircraft that required more maintenance, more skilled pilots, and more training time, while providing inferior performance against modern opposition. American units operated aircraft that were easier to maintain, easier to fly, and superior in combat performance. The cumulative effect created an overwhelming American advantage that German skill and tactics could not overcome. Superior aircraft, produced in larger quantities and flown by adequately trained pilots, achieved air superiority through simple numerical and technological dominance. The final encounters between Bf 109 seconds and P-51 seconds occurred during the closing months of the war, when desperate German pilots flying fuel-starved aircraft engaged American formations that held every conceivable advantage. These battles were less contests than exercises in technological supremacy, demonstrating the decisive importance of industrial capacity and engineering excellence in modern warfare. The lesson proved enduring. Post-war military aviation development focused intensively on achieving technological superiority, recognizing that superior equipment could overcome advantages in training, experience, and tactics. The P-51's dominance over the Bf 109 established principles that continue to influence fighter aircraft development today. The story of these two aircraft represents more than a comparison of technical specifications. It illustrates the decisive importance of design philosophy, manufacturing capability, and strategic vision in determining military outcomes. The Americans built a better fighter through superior engineering and industrial capacity. In aerial combat, that advantage proved insurmountable. German pilots, who flew against the Mustang, carried their respect for the aircraft throughout their lives, acknowledging its superiority while maintaining pride in their own service and sacrifice. Their admission that the Bf 109 was outmatched stands as the ultimate validation of American engineering achievement and industrial might. The technological revolution represented by the P-51 Mustang's superiority over the Bf 109 marked the end of one era in aviation history and the beginning of another. German air superiority, built through years of careful development and combat experience, ended abruptly when confronted with aircraft that simply exceeded all previous performance standards. The pilots who witnessed this transition understood its significance immediately. They were not just observing the replacement of one aircraft by another, but the demonstration that technological advancement could render years of experience and tactical development obsolete virtually overnight. This realization influenced military thinking for generations, driving continuous technological competition and establishing the principle that maintaining technological superiority was essential for military success. The P-51's victory over the Bf 109 proved that in modern warfare, the nation with better equipment would ultimately prevail. The legacy continues today in every fighter aircraft that prioritizes performance over tradition, capability over heritage. The Mustang's triumph established that excellence in engineering and manufacturing could overcome any advantage in experience or tactical skill when the performance gap became too large to bridge. The German pilots who admitted their aircraft were outmatched had learned this lesson through bitter experience. Their honesty in acknowledging American superiority stands as testimony to professional integrity and recognition of engineering excellence that transcended national boundaries. In the end, the Luftwaffe pilots who intercepted P-51 seconds at 440 miles per hour and realized their Bf 109 seconds were outmatched had witnessed the future of aerial warfare. They had encountered aircraft that represented the next generation of fighter design, built by a nation whose industrial capacity and engineering capability exceeded anything Germany could match. Their admission of inferiority was not a confession of personal failure, but recognition of technological reality. The Americans had built better fighters, and in the unforgiving mathematics of aerial combat, better equipment proved decisive.